Hello again, grade sevens. In today's lesson, we are going to continue to develop our algebraic skills. And we're going to continue to look at one-step equations. One-step equations means you can perform a single operation to solve it. However, I've referred to it as level 2, just because it's maybe slightly more difficult in comparison to the level 1 equations, but really not that much more tough. The learning outcome is to model and solve concretely, pictorially, and symbolically problems that can be represented by linear equations of the form ax equals b, x over a equals b, where a cannot be equal to 0, where a, b, and c are whole numbers. We're actually going to drop the algebra tiles and cups and counters this lesson because I find they're more trouble than what they're actually worth at the end of the day when dealing with the multiplication and division. Okay, so level 2 equations can be in one of the following forms. They can be in the form ax equals b, or they can be in x over a equals b. A and b can be any integer value. So an example of this might be, so let's grab the pen. You could have like 3x is equal to 15. Okay, so a is 3, b is 15. Or you could have x divided by 4 is equal to maybe 7. Okay, so a is 4, b is 7. Okay, so we'll do this using both the methods outlined last time. We'll use the inspection method, and we're also going to use the isolation method. Okay, so example 1, solve for the following variables using inspection and check your answers. Okay, so inspection means guess and test. So first things first, when you see the equation 4k equals 36, that's the same thing as writing down 4 times k is equal to 36. And what we want to do is we want to guess what is the value the variable needs to be so that both sides of the equation are going to be the same. So what I would ask myself is 4 times what is 36? Well, it should be 9. So we guess k is equal to 9. So what I'm going to do is I'm going to take k equals 9, and I'm just going to plug it in for this value and make sure both sides of the equation are the same. Okay, so let's go ahead and do this now. So now we're going to test. We test it by going 4 times, okay, we're replacing k with 9. And that would be equal to 36. Okay, 4 times 9 is 36. That's also equal to 36. So left-hand side is the right-hand side. Check. Okay, so it's confirmed as long as both sides of the equation are balanced. Okay, if you do not get the same thing, it means you have to go back and guess a different value for the variable. And that's fine. If you don't guess it on your first try, just keep guessing, testing until it works. Okay, this one, m over 2 is equal to 7. So just a quick reminder, whenever you see a fraction does mean division. So you have m divided by 2 is equal to 7. Okay, so we want to guess a solution here. Okay, so what divided by 2 is 7? So what, when we cut it in half, would be 7? Well, that should be 14. So we have m would be equal to 14. So we are going to then take m equals 14, and we're going to plug it in for m and just make sure that both sides of the equation work. So this would then be 14 divided by 2 is equal to 7. 14 divided by 2 is 7, which is equal to 7. Since both sides of the equation are the same value, it means we guessed the answer correctly. So that would be m equals 14 for b and k equals 9 for a. Okay, so that's my inspection or guess and test method. 2, I want to apply the opposite operation. And again, just a quick reminder, the opposite operation method is the one where we apply the isolation technique. Okay, so we want to get the variable on one side of the equation by itself. And again, we do that by applying opposite operations. Now, in this case, we're dealing with divisions. We're going to have to worry about multiplication and division being opposite operations. Okay, so let's go through a bunch of examples here. All right. Let's just do it in this color. Okay, so the first one, we have 3t equals 18. So I'm going to pull it up over here. Now, 3t equals 18. That is 3 times t equals 18. Now, we want to get the t isolated. So right now, the t is not isolated on one side of the equation because it's being multiplied by 3. So how do we get rid of that 3? Well, what's the opposite operation of multiplication? It is division, okay? And we're going to show that division with the fraction symbol, okay? So the opposite operation of multiplication is division. So we're going to divide both sides of the equation by 3 to get rid of that. Now, in terms of why this works, well, 3 divided by 3 is going to be 1. So it's going to leave me with a numerical coefficient of 1, which will just turn into regular t. Then the t will be isolated. Once again, whatever you do to one side, you must also do the other side of the equation. So if I divide this side by 3, I also need to divide this side by 3 as well. Okay, so what would this turn into? Well, 3 divided by 3 would be equal to 1. So you'd have 1 times t would be equal to 18 divided by 3 would be 6. We don't need to show the 1 as a numerical coefficient. So we can simply write down t is equal to 6. Oftentimes in math, when we actually take a number and divide by the same number, we can show them being crossed off. So this is like more common mathematical convention where you say 3 divided by 3, you put cross, cross. They cancel each other off. The 18 and the 3 don't cancel each other off. They divide evenly, but they don't directly cancel. Okay, let's do the second one. So second one is 72 is equal to 9t. So that'd be the same thing as writing 72 is equal to 9 times t. Okay, we want to get the t isolated. And right now the t is not isolated because it's being multiplied by 9. So how do you get rid of that 9? Because again, we want to isolate the t. Apply the opposite operation. What's the opposite operation to multiplication? Division, which again, we're going to show with a fraction symbol. Okay, so to get rid of this 9, we go 9 divided by 9 because that's going to turn this into 1. But whatever you do to one side, you got to do the other side as well. So we go 72 divided by 9. Okay, so this would then be 72 divided by 9 is 8. And then 9 divided by 9 is 1. Multiplied by t. We don't need to show that 1. So this would just be 8 is equal to t. But when we write down the solution to an equation, we like to write the variable first. I'm just going to flip the sides here. I'm just going to say t is equal to 8. And once again, we can use this little notation where we cross things off. So 9 over 9 would just cancel off. Okay, next one. You have 7 is equal to d over 5. Okay, so I have 7 is equal to d over 5. Now, the d is not isolated. So why is it not isolated? Because it's being divided by 5. Okay, so again, fraction means division. So what's the opposite operation of division? Well, that would be multiplication. Okay, so we're going to put the multiplication symbol up here. So to get rid of it, we're going to multiply by that same number, 5. Now, the reason this works is because if you have a 5 on the top and a 5 on the bottom, they'll just cancel each other off. But let's worry about that in a moment. Okay, so if I multiply this side by 5, you also have to multiply this side of the equation by 5. So we're going to write it like this. We're going to say times 5, okay? 5 times 7 is that. Okay, now we can show the variables cancel, or the numbers canceling off. So a 5 on the top cancels the 5 on the bottom. So this would then turn into 5 times 7 is 35. And then 5 divided by 5 is 1, so that'd be d times 1. We don't need to write down the 1 there, okay? So we can just simply write down the solution to the equation, which would be d is equal to 35. And again, just flip it around so the variable's on the left and the value the variable is equal to is on the right-hand side. Okay, this one, I got x over 3 equals 8. So x over 3 is equal to 8. Okay, so why is this x value not isolated, the variable? Because it's being divided by 3. What's the opposite operation of division? Multiplication. So we're going to put that multiplication operator up on the top here. Okay, so we're going to multiply by 3 to get rid of it. Because what that's going to do is you multiply by 3 on the top, and the 3 on the top and the 3 on the bottom are going to cancel each other off. Now, again, whatever you do to one side, you got to do to the other. So if I multiply this side by 3, I also got to multiply this side by 3 as well. So this would then turn into 1 times x would be equal to, what's 8 times 3? 8 times 3 is 24. 1 times x would just be x. You then have x is equal to 24, and that is the solution to the equation. Okay, and again, we can do these equations using isolation, or we can use isolation, opposite operation, or we can use inspection, guess, and test. But again, I'm trying to get you to understand the fundamental building block of the isolation method now, because we need this moving forward to deal with more complicated equations. Okay, that's it for this lesson. You can complete on page 406, questions 6, 7, 9, 10, 12, and 13. And the next lesson, we're going to wrap up the unit on solving equations. We're going to start to look at some two-step equations. We're going to apply a couple of operations to solve them. And I'll talk to you then.